In this video, we will be investigating radicals. What does a radical sign look like? You've probably seen them before. You've seen this one. It's called the square root. Then we have what's called a little index. That would be the cube root, fourth root, fifth root, and on up to whatever root. Sometimes it's even called the nth root. But let's just start with the basics of a square root. And what does that symbol mean to find? It means to find a number multiplied by the exact same number that would give you that. In this case, 49. Now I know that 7 times 7 is 49, and the square root of 49 is just 7. So what about this one? You could look at it as the square root of 1 over the square root of 81. Now what times what is 1? Of course it's 1. And what times what is 81? We know that that's 9. So the square root of 1 over 81 is 1/9. But what about here? What two of the exact same numbers could be multiplied to get a negative 16? Well, a positive 4 times a positive 4 is positive 16. And a negative 4 times a negative 4 is still positive 16. We can't mix a negative and a positive because a square root means what number multiplied by the same exact number would give you the inside here. And in this case, there is no real number. And so that's what we want to put, no real number. So now let's look at the cube root. The cube root asks you what number multiplied by itself 3 times in a row would get you, in this case, 8. Well, hopefully you remember that 2 times 2 times 2 is 8. So the cube root of 8 is 2. So notice, if you're a card player, we're looking for 3 of a kind. Now what about this one? Don't be so quick to say, no real number, because negatives multiplied an odd amount of times is negative, as in negative 3 times negative 3 times negative 3 is negative 27. So the cube root of negative 27 is indeed negative 3. What about that cube root of 1 over 64? Well, we can do the same thing we did up here, and we could separate that as the cube root of 1 over the cube root of 64. And the cube root of 1, of course, is 1. 1 multiplied by itself is always 1, however many times you have. And then 64, you might remember when we were factoring cubes that 4 times 4 times 4 is 64. So the cube root of 64 is 1/4. Before we leave these examples, I want you to pay close attention to this versus that. Couldn't take a square root of a negative, but I could take the cube root of a negative. So now we've looked at square roots, cube roots. Hopefully you're getting the pattern. What's a fourth root? It means to find something multiplied by itself, times itself, times itself, times itself 4 times. All right, so we really want to break down 16 into the prime factors. I know you know that 4 times 4 is 16, but if you break that apart, you have 2 times 2 for that 4 and 2 times 2 for that 4. And so 4 2's make 16. So again, I have 4 of a kind. So the fourth root of 16 is just 2. Now here, don't be so quick to say, that's not real. We need to use order of operations. We need to do this first. So if I have negative 2 times negative 2 times negative 2 times negative 2, we have an even amount of negatives, so that's positive 16. So this problem is really asking us to find the fourth root of positive 16, which we just found, which is positive 2. Again, kind of tricky. How is that different from this problem? Well, there's no parentheses, there's no power. This just says find the fourth root of negative 16. Well, if you have an even amount of negatives, you get positive. If you have an even amount of positives, you get positive. The only way you're going to get a negative is if you throw in a negative in there. So this is not possible. This is not real. So let's take this one step further and let's look at the fifth root of 32. Well, again, I suggest that you break down 32 into something that you know, maybe 4 times 8, and I know 4 is 2 times 2, and 8 is 2 times 2 times 2. So how many 2's do I have? I have 5, so I'm looking for 5 of a kind. The fifth root of 32 is 2. What about negative 32? Can I do that? Is it real or not real? Well, again, I have an odd amount, so if you think about it, if you have 5 negative 2's multiplied together, that's going to be negative 32. So the fifth root of negative 32 is negative 2. What about this problem? Well, it's just like this one, in that we have to do this first. Okay, or can we just write it out kind of like this? Well, let's see. I think I want to do that. So I want to take the fifth root of, and what does this mean? I have 5 negative 3's. And this is going to be, if I multiply 5 negatives, I'm going to get a negative, just like here. And so since I have 5 of a kind of the same thing, that's negative 3. Now notice that's different than here. I had to multiply all those together, and an even amount of negatives gave me a positive 16. And so that's how this problem is different than this problem. So hopefully now you've got some type of conclusion. And the conclusion should be that an even root of a negative number is not real, like that, but an odd root of a negative number is a negative number, like that. This is very, very important. This will save you a lot of time and trouble if you just were to memorize those facts. The next thing we're going to look at is a very easy exercise. We're going to convert rational exponents, fraction exponents, to radicals. Very simple process. I know it looks scary, but don't panic. This bottom number tells you the root. This top number tells you the power. So if I want to convert this to radicals, what I do is I take the 8, I take my radical sign, and the root goes right there. You have to be careful. I need to be able to read it. And the power can go inside, or we could write it as the ninth root of 8 raised to the fourth. Either way is perfectly acceptable. Let's do it again. So the bottom number is the root. The top number is the power. Alright, so that all stays together. So I have 5x squared y inside my radical. I need to take my root, goes right here, so that's the fifth root, and I need it squared. So I could put parentheses squared, or I can take the fifth root of 5x squared y all squared. You could leave it like that, or you could take this one step further and actually square that and say, well, that's 25 x to the fourth y. But all I really want you to learn is how to convert the exponents to radicals. The next thing we're going to do is go the other way. We're going to make the radicals into fractional exponents. Now I know you know that the square root of 49 is 7 because we've already worked that problem, but that's not the idea behind this exercise, is to see that radicals can become exponents. Right? So I'm going to take 49. Remember, this is a square root, so there's like an understood 2 there, and there's also an understood first power. So remember, when we talked about the fractions, the bottom number was the root, and the top number was the power. So a square root is the same as the half power, and we also know that that's 7. Okay, so the cube root of 8 you should know is 2, but let's write that with exponents. So that is our denominator. Remember, we're going to take a fraction. That's our root. That goes on the bottom, and that's to the first power. So 1/3 power is the same as the cube root. So let's write that down. The half power is the same as a square root. The 1/3 power is the same as the cube root. So following that along, what's the same thing as a fifth root would be the 1/5 power. And of course that's 2, and that's 2 as well. So the 1/5 power equals the fifth root. Very easy pattern to see. It's very crucial that you understand that radicals and fractional exponents are indeed the same thing. Okay, let's look at these next two problems. Same thing, we're going to convert the radicals to exponents and simplify if we can. All right, so we have 7, which is the base, putting my fraction. That's my root, it goes on the bottom. This is my power that goes on the top. That's all you can do to that. Let's do this one. X is my base. That's my root that goes on the bottom. That's my power that goes on the top. And again, that's all you can do. Let's look at these last two problems. Again, we're converting the radicals to exponents and then simplifying. So let's take the base, which is p, the root is 5, the power is 20. Can you simplify that? Well, of course you can, because you know 20 divided by 5 is the same as 4. So the fifth root of p to the 20th power is p to the 4th power. Let's look at this next one. So let's take that base, 5x squared, y squared, keep those parentheses, draw the fraction. That's our root that goes on the bottom. This is our power that goes on the top. Just like the last problem, we can reduce that fraction. So we have 5x squared, y squared, raised to the 4th power, and we could simplify that even further because we can distribute that 4th power to everything inside here. 5 to the 4th power is 625. We're going to multiply those exponents, multiply those exponents. So this is a very easy lesson. We're just simplifying square roots, cube roots, fourth roots, fifth roots by trying to find 3 of a kind, 4 of a kind, 5 of a kind, do some prime factoring. Remember, the even root of a negative number is not real. Odd root of a negative number is a negative number. To go from exponents to radicals, you take the fraction and rewrite them. And then from radicals to exponents, vice versa. Again, very easy lesson. You're going to do great.